खोपाटे सर.
येस सर, आवाज येतोय का माझा?
हा येतोय सर, येतोय. आपले गेस्ट जॉईन झाले का रिसर्च पर्सन? हो सर, जॉईन झाले.
हो, जॉईन झाले. गुड मॉर्निंग सक्ते सर.
गुड मॉर्निंग. आवाज येतोय ना माझा?
येस येस, क्लिअर येतोय.
सुरू करा सर.
हो सर, येस.
हो चालेल.
सक्ते सर, आपण इव्हेंट सुरू करूया.
हो.
நம்ம போய் கடையில வாங்கினாதான் அவங்களுக்கு அதுல லாபம் வரும். அதை வச்சு அவங்க பர்ச்சேஸ் பண்ணுவாங்க. அவங்களோட தேவைக்கு என்ன வேணுமோ அதை அவங்க வாங்கிக்க முடியும். இப்போ
Very good morning to all the dignitaries and participants. I welcome you all in a national webinar on data sciences and introduction and its applications, jointly organized by Department of Mathematics, Statistics and Computer Science, Dahibadi College, Dahibadi, under Lead College scheme. May I now request to our Honorable Principal, Dr. S.T. Salunke sir, to inaugurate today's webinar by putting his views regarding this event. Honorable Dr. S.T. Salunke sir. Sir, please.
ధర్మపురి వెళ్ళలేదు ఎప్పుడు వెళ్తాను తెలియదు, సడన్గా వెళ్ళిపోయాను. చెప్పరా? ఏదైనా
Honorable Dr. S.T. Salunke sir, please put your views, sir.
अनम्यूट केलंय. मी बोलायचं त्यांना काय मला कळलं नाही सर.
Sir, yes, please put your views, sir.
Can I start?
Yes sir, yes, please.
Okay. Very good morning to all of you. First of all, I congratulate Department of Mathematics for organizing such wonderful webinar on data science and introduction and its applications. There are two reasons behind the word wonderful. First, the title of the webinar. As we know, nowadays knowledge regarding data science is as important as other basic skills. Most of the fields like business, medical, software development are occupied by the data science. Every student must be aware about data science. And the second reason is that, of course, today's research person, Dr. D.M. Successor, when I overlooked his biodata, I realized that he is the perfect person for this webinar. In very short period, he achieved the current post in Central University of Tamil Nadu. We're really proud of you, sir, Dr. Successor. I'm sure your presentation will motivate the students. Being the principal of this college, once again, I welcome you all and I convey my best wishes for the webinar. Again, I thank you, all the organizers. Welcome to this. Thank you.
Thank you very much, sir, for your best wishes and valuable guidance. May I now request to head of the Department of Mathematics, Mr. Amit Wadile sir, to introduce today's resource person, Honorable Dr. D.M. Sakte. Over to you, Wadile sir.
Thank you, Kopade sir. Am I audible?
Yes, sir. Yes, sir. There is one request to you, sir. Please mute unnecessarily.
Yes, sir.
Please mute. Some mics are on there, sir.
Okay, sir.
Okay, sir. Yes, please go on, sir.
Okay, good morning, everyone. It's a great pleasure for me to introduce our resource person, Dr. Deepak Sakte sir, who is going to talk us about the data science, introduction and its application. Dr. Deepak Sakte sir is Associate Professor and Head, Department of Statistics and Applied Mathematics, Central University of Tamil Nadu, Tiruvallur, India. Dr. Deepak Sakte sir is a statistician with interest to develop statistical methods for identifying necessary predictors for responses considered in a variety of fields of research. He is the principal investigator of a study on development of variable selection procedures in zero and multiple integrated models for count data. He is also interested in non-parametric tests for location scale and location scale problem based on rank set sampling scheme. He is actively engaged in developing methods for analyzing high-dimensional data. His ability to design and undertake interdisciplinary studies in collaboration with scientists from other fields are evidenced by the range of studies he is involved. He is an expert in data analysis using R software. Dr. Sakti is an associate professor and head of the Department of Statistics and Applied Mathematics at Central University of Tamil Nadu since December 2019. Previously, he was an assistant professor in Department of Statistics, Shivaji University, Kolhapur, since December 2010 to December 2019. He started his career as an assistant professor in Department of Statistics, Savitri Bainabai Chaudhary, North Maharashtra University, Jalgaon, since December 2009 to December 2010. He did his bachelor's, master's and doctorate in statistics from Shivaji University, Kolhapur. He qualified CSR NET exam conducted in December 2008 while pursuing his MSc. He is also qualified ISS in November 2008 and was offered position of JTS officer, that is super class 1 post, in Central Civil Services of Government of India. He visited USA as an exchange visitor for postdoctoral research at Department of Biostatistics and Epidemiology, Augusta University, Augusta, Georgia, since August 2015 to July 2016. He is actively involved in clinical studies related to dementia and obesity in American children. He is a life member of ISPS, IISA and SUSTAN. So this is the brief introduction of our today's resource person. So now over to Kopade sir. Kopade sir?
Yes. Thank you, Vadile sir. May I now request our resource person, Dr. D.M. Sakte, to share his presentation. Over to you, Sakte sir.
Thank you very much, Mr. Abu Kopade.
Just a minute, sir. Vadile sir, please make him host, sir. Co-host.
Okay.
Let me check whether it is still disabled.
Yes, sir.
Still disabled.
Kopade sir, okay?
No. Please make him co-host, sir.
Only Sakte sir, Kopade sir. Okay, only 3 unmute.
No. Don't unmute, sir. Please make him co-host.
Okay.
Sakte sir, you are no co-host, sir.
Yeah, I can see now.
Okay.
Is my screen visible?
Yes, sir. Yes, it is clearly visible.
Okay. A very good afternoon, rather I could say a very good morning to all of you. I'm indeed delighted to be a part of this one-day national webinar organized by Daivadi College, Daivadi. And it has given me a lot of pleasure. The moments when I talk to people in Maharashtra, particularly on the topics of my interest, which include data science as one of the prominent topic, and it is one of the current stream which is flourishing like anything in the field of analysis. First of all, I would like to thank the organizers of this national webinar, Department of Statistics, Department of Mathematics, and Department of Computer Science of Daivadi College, Daivadi, for inviting me and giving me an opportunity to express my views on data science and introduction and its application. Also, I would like to thank the principal of this college, SP Saranchesa, for giving me this opportunity. So, friends, the topic of today's discussion is data science and introduction and its applications. So, I shall take you through the two basic concepts in this field. One is data science and other is data analytics. Both are like complementing each other, or rather I should say data analytics is a part of data science, which is now popularly being applied in the field of data management. And I shall also talk about some popular machine learning tools which are part of data science, and will illustrate these procedures with the help of some examples so that you'll understand like how exactly these methods are applied in real life and what sort of questions can be answered by using these techniques. At the end, I shall try to throw some light on the job opportunities in the field of data science. As well, I shall talk about some skill sets which are required in this particular field to become a data scientist, which is kind of the most hottest job I could say in current. Just to summarize, like this is again an application of data science which I am showing you on the screen. This is called as a word cloud, and this is usually used in the field of text mining, wherein we have textual data. Data is in the form of a text, and the prominence of certain words can be analyzed using text mining. So visual representation of the text data can be done by word cloud. So if we just give some query and find some results on this data analysis or data analytics particularly, then after creating a word cloud out of the important terms appearing in the concept of data analytics, we could see the most prominent term which appears is data. And you can see like statistics, then quantitative methods, deviations, analysis, and so on. So basically you could make out like this data analytics has statistics as one of the prominent factors in it. And the basis, I should say, the building of this data analytics is standing on the foundation of statistics. So without statistics, one cannot visualize data analytics. So basically, this is just like statistics is covered and a different label has been attached by many people, and then now it is commonly known as data analytics. But rather, there are some advanced techniques which complement the techniques which are used in traditional statistical analysis, and hence the name data analytics. So what is this data analytics? Data analytics is actually a process of inspecting, cleansing, transforming, and modeling data with the goal of discovering useful information, suggesting conclusions, and supporting decisions. So basically, it is used to extract useful information to support advanced decisions. The raw material for data analytics is usually data. Data could be in different forms, and usually it is in an unstructured form, which is required to be cleansed. First of all, inspected and then cleansed. Inspected to check whether it is in a proper format or not for further analysis. If not, then it requires cleansing, and once it is cleansed, there may be a necessity of transformation to a different scale so that further modeling of the data can be done. Based on the models, useful decisions can be made. So data analytics involves these steps, which are common to even statistical analysis. But the end model which is used, that may be different than the usual statistical procedure. And there is another term which is also popular in the field of data analytics, and that is data visualization. So analytics, of course, leads to modeling and then inference, but whereas graphically representing the data may also help to understand the hidden patterns and the importance of certain terms in the text. So visualization through the use of real-time plotting on dashboards could be a very interesting feature of understanding the data. So what are these, if we try to understand like how this data analytics is helping researchers and people in the industry to excel. So basically it starts with like answering the question, what happened? So you can see like I have put down certain questions like what happened, why did it happen, what will happen, and how can we make it happen. So these are different steps. Like if you start with like to understand a particular phenomenon, the question what happened can be answered using descriptive analytics. So descriptive analytics, of course, these are the part of your data analytics and all. So descriptive analytics can be used to understand what happened. Its difficulty level is low and the value is also low because it is easy to work it out. Secondly, the next question could be like, why did it happen? What happened that we can make out? For that, even this descriptive analytics sometimes may not be needed. Even one can use the domain knowledge and experience in the domain to make out like what happened. But the answer, why did it happen, can be given through data analytics using diagnostic analytics procedures. Then the question could be like, okay, what will happen? Meaning, if we make certain decisions, what will happen? Can we predict the future? Can we predict, say, for example, sale of a product? Can we predict the profit of a company? Can we predict the future of certain things which may hamper or may affect the progress of a given business, and so on? So predictive analytics can be used to answer the question, what will happen? And of course, these were the predictions which we could make out. But actually, if we target something like okay, we target that we shall be making a profit of so and so percent in the coming 10 years, then how one can do the business so that the target can be achieved. And this question can also be answered using prescriptive analytics, which is another part of data analytics. So basically the questions, what happened, why did it happen, what will happen, and how can we make it happen, can be answered through data analytics. So basically it is like climbing the steps from information towards optimization, or rather we can say from hindsight to foresight, which of course has higher difficulty as we progress in the either direction. So which has higher difficulty as well as higher value. So like prescriptive analytics is most valued thing in the field of data. But our today's topic of discussion is data science and not data analytics. But of course, without data analytics, one cannot imagine data science. What is this data science? Data science is actually kind of a combination. If you can see the screen clearly, I have made a graphical representation of some common terms and some non-common terms in different fields. So you can see like 3 different fields over there. The first field you can see is artificial intelligence. second one is machine learning, and the third one is data science. So artificial intelligence is having certain things which are not there in machine learning, and machine learning is having certain things which are there in both artificial intelligence as well as data science. And if you see data science is much bigger. It has things common with machine learning as well as artificial intelligence, along with its own methods, which are not part of either of artificial intelligence or machine learning. But if we try to put data mining here, so data mining and data science, they are more or less same. They are more or less the same, and you can say like data science and data mining, they are like two terms for the same task. So you might have heard these techniques like support-vector machine or decision trees, Bayesian learning, deep learning, KNN, and so on, which are part of like machine learning algorithms, and they are widely used for two basic purposes. One is classification, and other is prediction. Prediction based on regression setting. So we shall be talking about some of these methods soon, so that we'll understand like the core of data science. Of course, the initial procedures are also important, like data preparation, data manipulation, and preparing data for further analysis. Once it is done, after visualizing and all, either classification or prediction should be implemented. So we shall focus more on machine learning algorithms, which are of course part of data science, and we'll see some insight about these methods, and we'll understand like how they can be used in real life for implementing for performing certain tasks. Before moving on to specific algorithms, let us try to understand the basic structure of data science and how it is similar or different from data analysis. As I said, like data science and data analytics, they are inseparable. They cannot be separated from each other. And one can also say like they are the two sides of the same coin. So on one side, you will see like the data science indulges in discovering new and unique questions that can drive business innovation, whereas these questions can be answered or the solutions to these questions can be found using data analytics. And of course, the answers, or rather the questions which we are actually targeting, the solutions may determine how one can foster the data-driven innovation in a business. So basically, this data science and data analytics, as I said, they can be considered as a two sides of the same. So let us try to just pictorially map like when it comes to the term data science, what are the things which immediately come to our mind? Let me tell you, this is not an exhaustive mapping of data science. There could be more terms which I have not included, but these are the popular terms which are used in the field of data science. So regression, you can classification, feature selection, text mining, time series, deep learning, recommendation engines, anomaly detection, association analysis, clustering, and so on. Popularly used techniques are classification and regression, and of course clustering as well. And this feature selection can be an intermediate step either for classification or regression, and even for time series forecasting as well. And if you are actually interested in predicting or classifying the data which is in the form of images and all, one may need to go for deep learning procedures, which require more number of steps as far as learning procedure is concerned. Of course, there are stages in deep learning. In first stage, a model is built. In the second stage, another model is built, and finally, an ensemble of models is worked out to perform deep learning. So we'll touch upon some of the aspects of these procedures now. So these are the things which I will try to cover with the time constraint in mind. Of course, I cannot say that I can cover everything, but I can say simply like part of this procedure. So let me begin with the basic terms used in learning, that is supervised learning and unsupervised learning, and then I should talk about model building strategy in machine learning, and then we'll talk about some classification procedures. So supervised learning is actually learning in the presence of a tutor, or you can say like learning in the presence of a supervisor. So what exactly it means in the field of machine learning? It means like the system or a computer is trained based on the previous data. This previous data has the values on the response variable as well, and because the values on response variable are available, the values on the regressors, they are mapped to these response variable values so as to understand the pattern, and the system or a computer is trained over the previous data. And then the learned model is used either for classification or prediction, depending on the nature of data. The response variable may be having a class label, in which case you will be doing classification, or it may have a numerical value or a real value, in which case you will be doing prediction. So this is kind of an analogous task of analogous to particularly like learning from a teacher. There is another type of learning called as unsupervised learning, in which case the system trains on its own by learning the patterns from the data. So particularly it's like learning through experience. It is kind of learning through experience without any tutor or help. And particularly the procedures like clustering, they are actually the part of unsupervised. So these are the two major tasks which these machine learning algorithms perform, and even they are actually the part of data science. So what are the major tasks? Prediction methods and description. So prediction methods, you can select some variables to predict unknown or future values of the other variables. Values could be discrete in the form of classes, or they could be real when you have the problem of predicting a response variable, particularly in the setup of regression. And you can also go for like descriptive methods, wherein one needs to just understand the patterns available in the. So understanding patterns can be done either by graphical representation or even with the help of certain high-level models like hidden marker models. So, so these are some basic steps involved in a model building process. So initially, one needs to develop an understanding of the purpose of the project, why the project is being implemented. And depending on the purpose of the project, that is actually nothing but like understanding the objectives. Once the objectives are understood, then the data could be obtained. Corresponding data could be obtained so that the objectives can be met. Once the data is obtained, then the data science procedure will start. So, I request the organizers to mute the participants. Yeah, can you mute the participants, please? Yeah, thank you. So, the third step which I was talking about is like it is actually the first step in the process of model building, which involves data science, particularly explore, clean, and pre-process data. Once the data is prepared for analysis, then the data is actually partitioned into usually two sets, but sometimes three sets as well. The two sets could be training and testing, and if one is interested in partitioning it into three sets, then it could be training, validation, and testing. The training is the data on which the model is trained or model is learned by the system, and validation is the data on which it is validated, and the testing is that data on which the model is tested for its efficacy. So So they are mutually exclusive sets. These are mutually exclusive sets of the data, usually in the percentage like 60, 20, and 20, something like that. Sometimes if you are just having like a training and testing, then training would be like 70% of the data and 30 would be testing. 30% would be the testing. Organizer, can you please mute the participant? Thank you. So determine the data mining task or machine learning task, particularly either classification or prediction or clustering or whatever the task which is pertaining to the objectives of the project, and then further proceed with the choice of appropriate technique. Once the technique is chosen, then algorithms are used to perform the task and results are interpreted based on the domain knowledge. Once this is done, and once the model is validated properly on the validation data set as well as tested on a testing data set and found suitable, the model is deployed in real life applications. Deployment of the model is the final stage in the process of model deployment. So what is this training? Oh, already I discussed, so I shall skip that part. So this is the graphical representation of the training data is used to build the model, which is evaluated, maybe again built and evaluated till it becomes okay, and then testing data is used for the final evaluation. Of course, one can put validation before the model is deployed. So once model is validated on the validation data set, it will be finally deployed for the real life application. Yeah, so this is another pictorial representation of empirical model. Let me tell you, in usually in machine learning, we shall have empirical models rather than analytical models. Empirical models are the models which are learned from the data, sometimes which may not have any mathematical representation. Of course, we can write it in some way, but in practice, when it is implemented from the black box of the system, and we may not have proper mathematical expression to explain the model. But the patterns are learned from the data, and every time a new observation is applied, the model is used to predict the response for the corresponding new observation. So as I said, I shall touch upon certain classification procedures. It will list down certain popularly used procedures. Then one should not forget to mention decision trees, naive-Bayes classifier, k-nearest neighbor classifier, artificial neural networks, support vector machine, logistic regression, which is a hardcore statistical procedure, and of course, the list doesn't end here. There are so many other procedures for purpose of classification, but because of time constraint, I guess I may not be even able to discuss all these procedures. But I just listed down some for you, and there are procedures which are used to improve the classification accuracy of a given class.
Good.
So,
Now next question, sir.
So let us try to understand the procedures based on certain examples. So let me motivate the problem of classification through certain examples. Imagine a situation, usually such a situation may be there when a crime is particularly investigated, and the police or the investigation team may be confronted with a skeleton of a human being. And the problem is once the skeleton is available, whether the skeleton belongs to a male or a female, that is not known. So, in the respect of identifying, uh, identifying the person whether the skeleton belongs to a male or female. This question can be answered using classification process. How? See, by looking at the skeleton, one cannot make out whether the skeleton is of a male or female, but because of the structures and the different length of bone of a human being, it is possible. It is possible in the sense like one can get the anthropometric measurement, particularly of bones of skeleton in the pelvic region, which are significantly different for males and females. So, a model can be developed based on the previous data for which the gender is known and measurements are found on the different bones in the pelvic region. And then once the new skeleton is found, only these measurements are taken and put in the model to predict the gender. So gender can be predicted. I am saying predicted, not identified correctly, but can be predicted using a classifier. Another situation could be like in banking or business. Say for example, if a funding agency or a banking agency is actually interested to provide some credit or loan to customer. So before providing credit or loan to a particular customer, the agency may be interested to predict whether the customer will be a defaulter or a non-defaulter. Because if the credit or loan is given to a person who is highly likely to be a defaulter, defaulter is a person who doesn't repay the loan. If the probability of the new customer of being a defaulter is high, then it is highly likely that the customer will not repay the loan, and the bank may be in loss. So this question, answer to this question is very much important. Before providing the loan to a customer, of course, the bank needs to have an answer to the question whether the customer will be a defaulter or a non-defaulter. If probability of the customer is probability of customer being a defaulter is high, then definitely bank will not give loan to such a customer. Okay, we can see like several variables or indicators like financial status of a customer, particularly income, liability, credit risk, and so on, can be used to develop a classifier. And there are so many other fields in which one can have applications of classification procedures like epidemiology or engineering. So what is classification? Classification is actually concerned with like previously unseen records should be assigned a class as accurately as possible. So this is the goal of classifier. So always there is a class level variable available with the data, and corresponding to all the characteristics or variables which are available on given units of study, class label or class or label variable is always available. Then a model is built up, and whenever a new observation is available, then a class is assigned based on the model, classifier model. So basically, what classifier does, given a collection of records, which is of course a training set, each record which contains a set of attributes, one of the attributes is a class or label, and a model is built up for class attribute as a function of the values of other attributes. If we want to see a particular application of this classification in the field of telephone industry, then the problem, this is a very common problem which everybody might have faced, or even everybody might be a part of it. Like when Geo network was launched, many of the existing customers they for Geo by leaving their earlier network provider or network service provider. And again, some other network companies came forward, and again the transition of customer from one network service provider to other network service provider is happening, depending on the incentives, the plans, and offerings given by these service providers. So, as a service provider, the service provider is very much concerned about his existing customers, in the sense that if he loses this customer, he loses the business. So he wants to understand how likely he will be losing his customer to a competitor. So the goal is to predict whether a customer is likely to be lost to a competitor. And what would be the approach? The approach would be, so like whatever the transactions, whatever the calls, or whatever the transactions the customer is doing in the past, okay, and of course this will happen for all, with the past as well as present customers, to find several variables. What could be the variables? One variable could be how often the customer calls. How often the customer calls, like how much calls he is doing, where he calls, whether it is within state or within country or outside country, what time of the day he calls most. Yes. So these could be some indicators of a person's behavior with a particular network service provider. So basically, based on this, a label to the customer is assigned as a loyal or disloyal, and then a model is built for the loyal. So this is usually an application of customer acquisition of customer churn, also popularly called as churning of customers. Right. So, what is classification? Classification, already we saw, like, is a two-step process. In the first step, a model is constructed, and in the second step, it is used for classifying future or unknown outcomes. Accuracy is estimated through several measures. There are so many measures, particularly one measure is like misclassification probability, and there are some other things like sensitivity, specificity, and so on. Even ROC curve is also plotted to understand how good is the classifier. This could be an example of a data which is a typical training data, in which you can see that age is one of the variables, and age is like, a categorical variable. Now, age less than or equal to 30, age between 31 to 40, and age greater than 40, something. And you can see like income, student, credit rating. These are the variables for a customer which is entering a store, entering an electronic store, and the manager of the electronic store is interested to predict whether the customer will buy a computer or not. So he has like data on previous customers, whether they bought computer or not, with their other information like age, income, whether the person is student or not, and credit rating. The target is to predict whether the customer buys a computer or not. Accordingly, the marketing strategies and all will be decided. So I shall be coming back to that data with the help of a decision tree. Decision tree is one of the widely used classification techniques. It is a graph, particularly with nodes and branches. We'll see like what exactly it is. So this is an example, like the previous data. A decision tree algorithm is actually applied, and we can see like the decision tree is constructed. Usually it is constructed in a top-down manner, where the topmost node is the root node, and the branches generate from the root. And to make a decision for a corresponding observation or a new observation, the tree is pressed down. For example, if we have a new customer, the first question we shall ask to the customer, what is the age of the customer? If the age is less than 30, then the second question we shall ask whether he is a student or not. If he is student, then it is highly likely that the customer will buy the computer. If he or she is not a student, then he or she may not buy a computer. This is how the prediction is. Again, for example, if age happens to be between 31 to 40, then we don't need to ask anything else. The customer may buy computer. So that is what is predicted, and so on. So accordingly, the other side of the tree can also be traced to predict or assign the label to a new customer. So how it is actually constructed? It is constructed using an algorithm called as a 3D algorithm. And as I said, it is a top-down recursive divide and conquer procedure to construct a decision. It starts with all the training examples at the root, and then goes on dividing the complete database in such a way that the information at every node is the highest. So gain in information is highest at the every node. Basically, like now you might be wondering why the tree started with age and why not student, or why not credit rating, or why not some other variable. The reason is the variable chosen for the first split, and of course for the subsequent splits, will be the one based on certain statistical measure or a heuristic measure. There are so many measures depending on which so many algorithms are available. Like versions of these greedy algorithms are available. Some popularly used statistical measures are information gain or gain ratio, or Gini index, and so on. The information gain usually leads to ID3 algorithm, which is a very popular algorithm in the field of construction of decision. So that's what I said. Like why age? It may have the highest information gain, and hence it is used for the first step. Remember, it is a binary tree. It is splitting. Finally, it is splitting into only one or only two things, either yes or no. The young nodes, they are called as leaf nodes. So when this algorithm starts, it stops when like all the samples for a given node belong to the same class, or rather there are no remaining attributes for further partitioning, that is like majority voting, or finally there are no samples left to separate. So that's what a decision tree is constructed, and that's how decision tree is constructed. And now we shall talk about naive-Bayes classifier. Naive-Bayes classifier, as the name suggests, it involves Bayesian procedure. So, being statisticians, most of the audience I know is having a background from statistics, and some time back they might have studied a very popular theorem in the field of statistics called as Bayes theorem. So, naive-Bayes classifier is actually based on Bayes theorem. And the word naive essentially tells us like it is a very new kind of naive is like newborn or something. So Bayes theorem as such, this is just a revision, you can say, like what exactly your Bayes theorem tells. In Bayes theorem, you might have studied two different types of probabilities. One is prior probability or prior knowledge about an unknown thing, usually a parameter in the field of statistics, which is to be estimated using the data. And the estimation is done based on the posterior distribution or posterior probability. So posterior probability is worked out by combining the information from prior with the collected data. So usually the posterior probability is given as probability of hypothesis usually we have H as an hypothesis. It could be your theta, or it could be your particular statistical hypothesis, or it could be your class level as well, which is there in case of nowadays classifier. So, what exactly it does? It actually predicts the it predicts the probability of a class given the observations of the respective variables, that is x1, x2, so on up to xn. And the prediction is done using the data and of course the basic. So yeah, so this is what actually it does. It predicts x belongs to Ci. That means x belongs to Ci. That is the statement which is given if and only if the probability of Ci given x is highest amongst all the other probabilities. Say for example, we are having three classes which should be assigned to the given x. Then probability of first class given x, probability of second class given x, and probability of the third class given x. All these three probabilities are computed, and x is assigned to a class which is having the highest posterior probability. So this is how the classification is. Practical difficulty is that it requires initial knowledge of many probabilities, because prior probabilities are to be worked out. Sometimes abundance of a class itself is taken as a prior probability, and usually it needs variables to be tested. So those things are there, and of course the independence may not be there, which is required to compute this posterior probability, and therefore an assumption is made. That assumption may be valid, may not be valid in certain cases. So it has some advantages as well as limitations. So already I've discussed this. So talking about this nearest neighbor classifier, this is a very intuitive way of classifying the observation. For example, if we look at the adage, a very famous adage that birds of the same feather flock together. Like those who are alike, they will be together. That's the basic meaning of this well-known adage. So what it says is like birds of same feather flock together. Same thing happens in statistics, in data as well. Observations belonging to the same class will be very close to each other. When I say close, I mean statistically or mathematically they are close. So the distance between these observations will be very, very close. So K nearest neighbor classifier uses this idea, this principle, and performs classification. So what it does, so it says like all instances correspond to points in the n-dimensional space, and the nearest neighbor are defined in terms of if all the variables are real, then Euclidean distance. But if all the variables are not real, then appropriate distances can be found. If they are all discrete, then some appropriate distance can be found, depending on the nature. Like some may be discrete, some may be binary, some may be real, some may be real in the sense like continuous, some may be measured on ordinal scale, and so on. Still, a distance can be found to understand how close these observations are. So, using an appropriate distance measure, the nearest neighbors are defined, and then a target function is identified, like whether it should be a discrete or a real value. Usually, a K nearest neighbor classification is more popular rather than regression. The classification is like in the data, all the observations corresponding to the nearest neighbors of the new observation are found from the data. So the new observation, whichever we have, for which the class is to be predicted. Corresponding to this new observation, we find all the nearest neighbors from the existing group, and then we give majority voting as a label to the new observation. Majority voting from the nearest neighbor. Their classes are looked into, and say for example, the nearest neighbor, say 5 nearest neighbors are found. So K stands for, like K we have to decide how many nearest neighbors we are going to see. So for example, if we fix it to be 5, then 5 nearest neighbor observations corresponding to a new observation are found, and their classes are observed. Out of 5, 3 observations are belonging to say class C1. 2 are belonging, one is belonging to C2, other is belonging to C3. So majority says that C1 is the class which is in majority. So new observation will be assigned to class C2. That is how prediction. This K nearest neighbor is a lazy learner. It doesn't do anything beforehand. It just sits idle. And whenever a new observation is there, then only it will start searching for the nearest neighbor and then assign the label based on the majority vote. There are so many advantages and disadvantages, but we are running out of time. So I shall directly move on to the job opportunity, which is an important aspect in this field. There are so many classification methods which I already told: logistic regression, artificial neural networks, support vector matching, and so on. And if the algorithm, classification algorithm is not able to produce a good classifier, then its performance can be boosted or enhanced using certain methods, particularly ensemble, which is like instead of using a single model, you use some T models or K models, and then based on the majority vote, we combine the votes, and then using majority vote, we give prediction. So that is actually ensemble procedures. Popular ensemble methods could be bagging, boosting, and usual ensemble, and so on. So I am skipping this part. And clustering, as I said, like clustering is a procedure of data segmentation, and it is an unsupervised learning procedure. There is no response in this. Patterns are built and particularly used to perform customer segmentation in the field of business analytics. There are so many ways in which this clustering can be done. One is like partitioning method. Then one can think of hierarchical methods, particularly agglomerative and divisive. And there could be like density-based methods and grid-based methods, and so on. So partition methods. So there are two popular methods. One is K-means and the other one is K-medoids. And of course, time series analysis, which is actually based on time dependent data, and it predicts the future in real sense. It predicts the future of existing series. So this is usually applied in the financial analytics field of data science. So you can see like there are so many ways in which this time series forecasting can be done with the traditional methods as well as machine learning methods. Association mining, these are the procedures which are usually used in marts, wherein the arrangement of different products is made scientifically using market basket analysis. So the purchasing pattern of a customer is studied closely, and the basket contents are studied. Basket in the sense like what he is actually purchasing, and together, like which items are purchased together frequently. Such frequent item sets are identified through FID algorithm, and association rules are mined from the tons of data, and it is applied to marks so as to enhance the business in that particular domain. Yeah, this is an important aspect which I just wanted to touch upon, like having understood or having known like what are the techniques which are usually used in data science, how one can become a data scientist, what involves three things. This usually I'll tell, like some of you may be undergraduate students, but I will say that you keep patience, you become a postgraduate in statistics, and then you will be equipped with the third skill set required, that is statistics. Once that is done, then you can have simultaneously you can have your skill set expanded to include some computing software like Python, R, SQL, and database management systems. And along with that, one can also try to understand certain data visualization tools like Prescriptive. If you have these things in your toolbox, then you can be ready to become a data scientist. So, as I said, you just need to keep in mind some data visualization tools, then some programming languages like Python, R, SQL, and TDMS, and of course the basic concepts of statistics, without which you will not be able to derive the correct insights from a data. I have just listed down certain popular roles of a data, many popular roles which are offered to a person who is good in data science. The very first term you can see is data scientist, which is like a very booming term nowadays. Then data engineer, data analyst, machine learning engineer, and so on. Data journalist, database admin, and so on. You can see like so many different roles are offered to a person who is having the skill set which I just showed on the previous slide. And the list doesn't end. This is just a representative list of some important and some commonly offered job roles. This list is not exhaustive. You can still find so many other roles when you have the skill set which I already showed on the previous slide. What are the key points to remember when you want to become a data scientist? First thing is that you should know your domain, because as I said, data science can be applied to finance, it can be applied to business, it can be applied to medicine, it can be applied to so many different fields or domains in which one should be, first of all, well versed. For example, you want to be a data scientist in the field of journalism, then you should know the domain first, that is the journalism, and then you can enhance your skills to become an effective data scientist in the field of journalism. So the name may be data journalist. Right? The first thing you should remember is know your domain, and of course, the second thing you should be is like you should be an expert in data analysis. And finally, connect the dots, use data to make smart decisions, and success will be yours. That's it. Thank you for patient listening, and once again, I would like to thank the organizers for giving me an excellent opportunity to interact with all of you. Thank you. Thank you very much.
Thank you,
I'm
sir.
open to
Yes, sir. Thank you. Now the session is open to all. If there is some query, please ask to direct Dr. Satya sir. He will try to answer it. Actually, Dr. Satya has explained so much things very deeply that the journey from information to optimization in various WH type questions, why, how, what, and so on, and how does data science vary or how it directly connected to artificial intelligence and machine learning and all. Then I think he has nicely explained that data science and data analytics, these are the two sides of the same coin. It means that, or does it mean, sir, it will never equalize?
Actually, they are not exactly same, but we can say like data analytics is the way of finding solutions, while data science is like finding questions or finding problems.
Okay.
The beginning stage, you can say. So they complement each other. Without finding a problem, there is no point in finding solution.
Yes,
So
yes,
first,
yes.
we should find a problem. This can be done using data science, and then the answer or the solution to the question can be found using data analytics.
Okay, 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 okay. Okay, there is one announcement for all the participants. You can have feedback link in the chat box. Please fill up it, and you have to wait for 1 or 2 days to get e-certificate, as technology matters. So sorry for inconvenience, but you have to submit the feedback form. Okay, is there any questions? Not regarding feedback link, of course. I think many of the students are from BTech, sir. Artificial Intelligence and Data Science.
For them, that artificial intelligence would be a very promising field. They can first enter artificial intelligence and then explore certain things from data science, combine it, and they may be doing very good in robotics and all, which is very popular nowadays. If you see like automated cars, like a car without a driver is kind of a robot, you can say, but with all kind of machine learning used to make smart decisions. Like if you see the Google's car or Tesla car, you can see like how these things are implemented over there. Particularly Google's one, it captures the data in the form of images which are taken from different cameras installed on the car, and then based on the image, distance, and all, a decision is taken whether the car will move with the same speed or stop or take a right turn or left turn. Everything. So these things are being automated nowadays.
Yes, 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 yes.
Sunil थोड़ा डबा के
Okay, Satya sir, shall we conclude?
Yes.
Okay. After a vote of thanks, we shall discuss for 5 minutes, and we'll give time to submit their feedback forms. Okay. After this energetic session, I declare that the session of today's webinar is over, and may now request.
Certificate mistake for certificate.
Yes, please, sir. I'm not really hearing you, sir.
Certificate, e-certificate mistake for cup.
He's asking regarding e-certificate. Am I right, sir?
Yes, sir. Yes, sir.
Okay. You just submit the feedback form.
The 2 days.
Yes, yes. Within 2 days, you will get.
My mail, sir. Mail.
Yeah. My mail. May I now request to Miss M.S. Magar Madam to deliver both of things. Over to you, Magar Madam.
Chat back certificate comes, sir.
On behalf of Ruby, I take this opportunity to propose a vote of thanks and conclude this session. In this session, sir has told about data science. Data science is a field in which people with a mathematics, statistics, and computer science work. It uses a technique like machine learning, cluster analysis, and data mining. First of all, I will like thanks our principal, Dr. S.T. Salunkhe sir, Dhevadi College, Dhevadi, for presence this webinar and also gives permission to organize this webinar. Then I would like to thank resource person, Dr. Deepak Sakti sir, for blessing today's webinar. Then I would like to thank Lead College Activity Coordinator, Dr. M. Khikre sir, and IQAC Coordinator, Dr. A.N. Dadas sir. Heartfully thanks to our student and my colleagues for actively participate on this webinar. Thank you all of you. Thank you, sir.
Thank you very much.
Thank you so much, madam. Mr. Wadile, Amit Wadile, sir, are you hearing me? Please once again put the feedback link in the chat box. Sir.
Abhi sir, can I leave now?
Okay, sir. Okay, thank you for your valuable time, sir.
Yes. Thank you very much. We'll talk
Yes.
later. Yes.
Yeah. I shall call you, sir.
Okay.
Okay.
Bye-bye.
Certificate. You will get certificate in this.
वाढले सर
Yes, sir.
लिंक शेअर करा चॅट बॉक्स मध्ये आणि 5 मिनिट चालू राहू द्या.
Good morning, sir. This is Neelaveni.
Yeah, good morning.
Sir, actually, I'm a faculty from an engineering college.
Okay.
So, is it possible to share the presentation, sir?
Yeah, okay. I shall call our resource person to get the presentation. Yeah.
Thank you so much, sir.
Yeah.
Useful, very useful.
Yeah. It was very
Need the
useful.
presentation. Okay.
Yeah.
Thank you, sir. Thank you.
Yes, welcome.